We will have Elizabeth Leo, who is here. Hi, Elizabeth.
Hi.
She's the project manager at Camp2Camp, the world leader of geospatial open source software. She has a surveyor background and she has been working in software dev since nearly 10 years now. And Niels Osterling, he's a geologist. He worked as geological data infrastructure coordinator. After the video, this video, Elizabeth will answer the question you have. Is it? Perfect.
Yes.
So we will start with the stream.
Welcome to the presentation of swissgeol.ch, the geological data on the web. swissgeol.ch is a web application for geological data, which is publicly and freely available as a beta version since mid-2020. In the talk, I will present the project in more detail and give an insight in how such a project is created and how it develops, about the triggers for the creation, a short excursion to the technology, and then a small demo of the result. The presentation will be closed by an outlook, and of course, I'll be happy to answer your questions. So, first about what triggered the project. Actually, in the beginning, there was nothing. Well, actually, nearly nothing. Switzerland has actually a lot of geological data, but it is hard to get it. There is still a lot of paper-based data, and also digital data is often still processed and delivered manually. Not only the form of the data, but also the content can be a challenge here in Switzerland. The data is often covering only a small part of Switzerland, and its quality can vary a lot. It can be in one part of Switzerland very, very precise, in the other part very rough or even non-existing. Some data is sometimes only mapped to the ground or relative to the ground, and the information is sometimes not located or not locatable in 3D. Based on this situation, the program NGM was started at swisstopo, and due to its high economic benefit, it became a so-called lighthouse project for the public administration. So there are several project parts, or the National Geological Model Program is divided into 4 different projects. One is about production of the data, the other one is about publication and visualization of the data, the third one is about cooperating and interoperability, and the last one is about the expansion of the existing infrastructure of the geological 3D models. We are working for the project NGM PUB, so about the publication and the visualization of the project. The goal of swissgeol.ch is thus defined as making the data easily accessible and available at any time without any cost or manual work to be done for the one who has to access it. So in the end, enterprises and public institutions shall use the data and thereby create an economic added value of about 6 to 8 times higher than the costs of the project. So swissgeol is really covering the part of the NGM PUB project. On the technical side, a preliminary study of possible technologies was conducted in 2018, and it was found that an open source approach offers the most potential and flexibility. The maturity of the technologies, especially in the open source area, but also the new possibilities in the web world, especially regarding WebGL, opened the way to go towards open source web solutions, which were typically based on CesiumJS. So we started the project development in the end of 2019. The basis of the project were already existing services, mainly of map.geo.admin, which is the Swiss cartographic or map application published by swisstopo, the Cartographic Institute of Switzerland. And in this map.geo.admin project, there was already quite some experience made with the 3D viewer. So they had, or they still have, a 3D viewer, and also some data they publish in this 3D viewer. But now with the Geology, we wanted to do one thing more, one main thing, of course. Before the 3D or the current 3D viewer of map.geo.admin is only covering surface data or above the surface, and now with Geology we want to go underground and look what is below the ground actually, and be able to visualize as many data as possible under the ground. The user should be free to navigate also on the ground, and this in a similar way as we know it already from other 3D solutions like Google Earth or CesiumJS. So really a high usability standard. So going towards underground navigation was one of the main challenges of this project, along with big data publication and missing standards. So for example, we are still in the way of defining geologic color schemes, or also how do we tile, how do we handle really big, large rock layers, which are actually similar to terrain layers or terrain data. So there were and there are still some quite big technological challenges, and there are also and there were main usability challenges, like how do we make it ergonomic, how do we communicate, how can the user go underground, how should it behave, and we were also going to a very strict user case focus. And of course, one of the main challenges for the usability was the performance. In order to make the development and the user expectations converge as fast as possible, we were sticking to a strict Agile Scrum framework over the entire implementation period. So we had really the technical part being in exchange very nearly with the project owner and finally with the whole stakeholders around the projects, and we released every 2 weeks actually a new version on production. So in the end, underground navigation capabilities were thus pushed to upstream CesiumJS, and in collaboration with Cesium, and around that a lot of data and geologic features have been implemented and passed through and they all passed through the alpha testing phase with real users. After about 7 months of development, swissgeol was born and the project in its beta state was released. So maybe just a quick short word about what technology was behind it. You already heard it maybe a little bit. We use CesiumJS, and we work together with Cesium also, especially for the underground feature. So this is something interesting because even though CesiumJS did not cover the main feature for swissgeol, the underground navigation, it was clearly the best choice given the navigation easiness, the performance, and the large support of different data. As you certainly know, a missing feature like underground is not a showstopper for open source projects and in this open source world. either by funding a new feature or by contributing to an open source project, you can take influence on it and join the community. That's also what has been done in the case of Cesium and SwissGeol. So we were really talking with Cesium, seeing what can we do to help them to get the underground done. So the main component is CesiumJS, but there's also a lot of data which we integrated and treated. And for the treatment of the data, we had to use a ETL product, a closed source licensed ETL product called FME, because the data formats were very, very diverse. We also integrated the login capabilities with a national AIM solution and added a lot of interfaces to other geological applications or map portals here in Switzerland. With the process data and the web services used, we have more than 20 layers now available in SwissGeol, and the data can be viewed in an easy and straightforward way for anyone who likes it. A large part of the data can also be downloaded directly in SwissGeol in its original format and be used in specific geological software. Now, after about 6 months of development, the beta version was published on swissgeol.ch, and since then it has been continuously updated and improved. I'd like to give you a short showcase or a short tour around the different features that are here, and especially show you some of the main features. So you see, you can look at SwissGeol in a 2D way, just from top down to the earth. But you can, of course, also tilt and see the mountains in a precise way. So it's a 2 meters precision terrain and height model that has been integrated. So from the Earth surface to underground, you can flip over to the underground place at the same place actually, and look how it looks like underground. So you will discover a lot of more things, like cross sections, boreholes, but also like the footprints of the buildings, and also earthquakes over the last 90 days, or some bigger earthquakes which are older. You can also show different layers. So here you see from today to the Ice Age, for example. You can travel back to the Ice Age and see how the Earth looked like, especially the Alps during the Ice Age, and see the whole ice coverage. One interesting feature is also you can vary the transparency, especially from the terrain, but for any other layer as well. So you can really explore and go have a look underground by staying overground, but see what is there and what can be of interest to zoom in or to have a better glimpse. So here you see, for example, in a mountain valley, you see the buildings, you see the mountains, but you also see in red and blue, you see the train tunnels and the road tunnels. We have, of course, a lot of different data, and you can kind of combine it. So here you see lakes and rivers with the buildings, with some cross sections, with some seismic transects, with different geological layers coming in, and then also the faults and some temperature models, as well as some surface geological map. So you can really see and combine a lot of different data and get a really new insight about what you see and what can be, what the geological situation might look like at specific places. You can also draw lines, but not only, you can use those lines to generate cuts and have like this a better understanding on different places. So for example, here I did a cut on a specific place near to Neuchâtel, and you can see, if you cut, you can see maybe all the underground layers you switched on, here some geological layers together with the folds. And you can not only just cut a specific place or just a simple cut, but you can also generate block models, so kind of a box cutting with slicing, and then interactively change the box sides, so really have some slicing and get some more insight of the data. But maybe sometimes you would like to kind of not have your box model, but get an insight from where you are, so you can not only slice a model, but also cut out a rectangular place and get insights and slice along this cutout. So maybe you analyzed some place, or you get an insight in some specific place. For example, here we have a borehole with the temperature points, the blue temperature points, and the red folds layer. And what you can do now is you can also annotate specific places. You can add images or website links in order to kind of remember what specific things or what findings you have found at those places. And yeah, so that's one part, but there's a lot more. You can also explore it yourself. There's a lot more to be done, and which is possible to do. We have extrusion of drawn geometries. We have a really precise terrain. Maybe we'll even go one step further with the terrain one day. We have some navigation cube, keyboard navigation, like a little bit gaming style keyboard navigation. We have the buildings integrated, we have multilingual features, search, drawing, and so on. KML upload. And there will be also more to come, of course. Yeah, but the main thing is it's free to use, and the whole code is open source. So even better, except, yeah, instead of just watching this presentation, let's try it yourself. Get the link, go online and try it. The code is also open source and can be forked and investigated, and we would be happy to get into discussion with you in case you are interested to use it, or if you see that it would be interesting in your region also to have such a tool. So I gave you an insight in the implementation of the SwissGeol project and the state we are today. SwissGeol fulfills the objective for an easy, performant access to geological data, and as an open source solution, it has the potential to address diverse geological stakeholders and get them on board. At the moment, we are still in beta phase, so there will be a lot more coming in the future. So this leads us to the future. We are planning to implement a brand new UI based on the beta experience and some UI expertise. And then we would also like to add a real voxel support with volumetric pixels, actually, typically for the temperature model, or also for other attributive voxel information. We also plan to add a lot of more analysis function and, of course, more and more data. And as a long-term goal, SwissGeol shall become a major tool for Swiss geologists and maybe also for the worldwide geology community. Maybe there will be some kind of community forming around the project, which which would be really interesting and a great plus value. So yeah, thanks a lot for your attention. And yeah, I'm the project manager at Camp2Camp, a service, a geospatial service company here in Switzerland, but also over Europe, and we are providing services all over the world. And I would be happy to discuss about the project with you and also get your questions and inputs. And yeah, thanks a lot for your attention.
Hi, Elizabeth. Thank you for your presentation. It's been really interesting for all of us. And we had a lot of interactions through the chat and a lot of questions. So we are going to start with the questions. Okay.
Okay,
So
great.
the first one is, are you having any type with project like one Geology, Loop, GeoSML?
No, we don't have. I actually I don't know them. So I'm more from the 3D GIS world. Niels is more in the geology. He can't attend today, but no, I don't know them. So I will definitely check them out as well. Thanks.
Okay, so we are going to the next one. What was the biggest challenge in this project? Big data, 3D tiles, or what?
Yeah, I think it's kind of around big data. It's really one part is the big data, and it's also like geologists are used to very specific data formats, which are most of the time not web compatible or not made for the web world. And on the other hand side, it's really the usability. So people are maybe used to Google Earth or to their specific geology tools, but they all have different 3D navigation possibilities. So to kind of catch the geologist users, it's one of the biggest challenge, I think, in this project.
Perfect, thank you. The next one. Do you have any needs about implementing IoT and digital twins? What will be the purpose of these technologies in the context of geology service to the community?
Yeah, so definitely. So let's say the users of SwissGeol in the Swiss context, let's say they are definitely interested to, for example, for construction work or things like that. They want to kind of show their digital twin in the context of the geology. So this is definitely very important also for tunnel constructions, to kind of combine it really with the geologic layers. And the other thing is for IoT, we already have something like that. Actually, we are using, we are kind of trying to branch on the different services which collect data from IoT. Like typically we have the earthquakes in SwissGeol currently, and they are actually taken from from a service which is the earthquake monitor in Switzerland. So it's up to date for each
Perfect,
day, actually. Yeah.
thank you. So the next one, what software 3D method do you use to draw geologic profiles?
This would be a question to Niels, but he's not here. Actually, all those data are pre-prepared before, and sometimes even they are prepared by companies who collect the data and so on, or by swisstopo. So I don't really know in detail what they. I don't know. Sorry.
Okay, don't worry. So the next one is, do you automate your data processing? If so, what tool do you use?
Yeah. So a part of it is automated. So we typically have some services we kind of take the data from, and we process them each day automatically with some GitHub actions. So this is kind of really it was an interesting solution to use for this kind of data. And then we have some other data. We process them manually with an FME, with this FME processing. So this is still manual. And then there are other services which are actually processed for the 2D part at swisstopo with bash scripts and so on, with a whole server infrastructure.
Perfect. Thank you. The next one, Alex commented into the chat. I wonder if this could be useful with other utility layers for using a copied place.
Yeah. So, for example, yeah, like I'm not completely sure if I understand the question, but I guess it's like yeah, in cities you have a lot of drainage tubes and water tubes and electricity, internet cables going on in the earth, and that's definitely one of the things which is useful here, because we know a lot what's happening overground. We know who has constructed what house at which height and so on. But underground, the world is a lot less clear, and it gets yeah. We have with every year we have less space on the ground because everybody tries to put something in. So yeah, it's definitely one of the goals why this project was actually launched. Yeah.
Perfect. Thank you. The next one, how is geologic layer information stored? Raster measures something else? Do you record only tops or tops and bottoms of a layer?
So at the moment we are like, especially for the geologic layers, we are working with tins, which we transfer to 3D tiles. But yeah, it's surfaces, so it's triangular surfaces, and we have like point clouds, which is now like the, let's say, the compromise to show some volumetric data, because we don't yet have voxels, but we would like them. So we have the point clouds for that, and yeah, so some other like objects and so on. So there's a lot with 3D tiles finally, which allow to do a lot of stuff. And I think we are mainly showing tops of the layers. You have to check in the layer tree in the data catalog what is available, but we choose that just to kind of avoid having double layers at one single place. Yeah.
Perfect. The other one is, can subsections of geological layers be exporters for reuse, like 3D printing?
Yeah. Some I'm not sure if yeah, some subsections can be let's say if you do them on the fly, you cannot export them yet. It's a goal later on. You can use an external tool to create a PDF of the subsection currently in SwissGeol. But there is some layers, or quite some layers, have the possibility to download the initial data. So the raw data, you can get it and then kind of really treat it and do your own fun stuff with anything with
Okay,
that
perfect.
data.
We will do another question, and then because we are out of time, so we are going to do another question, and then the audience please contact directly through Venules or your email. So the next one is, what kind of cost does the project generate for session long Ion?
Not yet a lot, because we don't have a lot of users yet, and the main data is hosted at swisstopo. So like the really data consuming parts are hosted at swisstopo, and we have we have some kind of intermediate plan or something with CesiumJS. So
Okay. Okay, Elizabeth, thank you so much for your presentation. And
you're welcome. Thanks.
please, to the audience, contact directly to another questions. And we are going to the last one for the morning session.